On the planet Trisolaris, 3 suns crossed the sky, and no one can predict which one will rise tomorrow. That's the world of the show 3 body problem, but the nightmare behind it is real physics. Newton wrote one equation that, for 300 years, never lost a planet. Pointed at 2 bodies, and gravity is perfectly predictable, forever. Add a third, and the most predictable force in the universe becomes impossible to predict. Start simple: 1 star, 1 planet. Gravity pulls them together. The planet's speed flings it sideways, and they settle into an orbit that repeats, the same ellipse, over and over. This is the 2 body problem, and it's been solved for centuries. It's why we can print eclipses in calendars hundreds of years ahead. 2 bodies under gravity are a perfect clock. Now watch what happens when we add just 1 more. Free stars, same gravity, the same simple law: every object pulls on every other. You'd think 3 is barely harder than 2. It isn't. With 2 bodies, gravity falls into a clean, repeating loop. With 3, every star is pulled by the other 2 at once, and those pulls keep changing as the stars move, which changes the pulls again. The motion never settles. It never exactly repeats. Poincaré proved it in the 1890s. For 3 bodies, there's no closed-form solution, no compact formula you can write down to jump to the answer. The only way to find out where the stars go is to simulate every step, and watch. But no formula doesn't sound so scary. Computers are fast. Why not just simulate it? Here's why. Watch these 2 systems. They start identical. Same 3 stars, same speeds, same positions. Except in the second one, I've shifted a single star by 1 millimeter. 1 millimeter, in a system the size of a solar system. For a while they match, then the tiny difference compounds, slowly, then all at once. Until the 2 futures share nothing in common, 1 star is flung into deep space over here and stays home over there. This is chaos, not randomness, but a system where the slightest error in where you start explodes into a completely different future, and perfect knowledge is impossible. And this isn't just a thought experiment. Look up. Alpha Centauri, the closest star system to our own, has 3 stars. Half the stars in our galaxy live in pairs, triples, or clusters, bound together by the same gravity. That's the real Trisolaris, a world whose suns wander unpredictably, lurching between frozen dark and scorching chaos no one can forecast. So here's a question. If you lived on that planet and the next chaotic era could strike at any moment, would you keep rebuilding every time, or leave to find a stable star? Tell me in the comments. Now, chaos isn't the whole story. Hidden inside the 3-body problem are rare, perfect solutions. 3 equal stars can chase each other forever along a single figure 8, a dance so precise it loops exactly. And there are calmer tricks, special balance points between 2 big bodies called Lagrange points. We park real spacecraft there. The James Webb telescope is sitting at 1 right now, held steady by the very problem that's supposed to be unsolvable. But most of these live on a knife edge. Nudge 1, and chaos takes it back. So, within Newton's universe, gravity is completely deterministic. Every motion follows 1 law with perfect precision. And yet, give it 3 stars and empty space, and it becomes something no equation can capture and no computer can outrun. The universe isn't unpredictable because it's random. It's unpredictable because it's chaotic, and chaos hides inside even the simplest rules. Newton wrote one equation that never lost a planet. He just never imagined what 1 more star would do. Follow for more science that breaks your intuition.